So, the vision that David presented yesterday for Rails was exciting, wasn't it? Yeah. This vision of Rails as a kind of rocket engine that can launch your idea from hello world to IPO is bold and beautiful. But for those of us who have already embraced this new no-pass mindset, I expect that you, like me, have probably felt like you needed to be a kind of rocket scientist to then deploy and run your application in production. And that makes sense, because much like rocket engines having really grown more complicated and larger with time, when you look at what we might call the standard web application architecture, that has also only grown more complex. If you take a typical Heroku application from 15 years ago, sure, it was a distributed system, but it was understandable and manageable. Well, this is the typical Heroku application today, where the number of services and servers has tripled. And I'm sure that many of you, like me, when I first saw this, think, well, this must simply be the cost of running production-grade systems. And it's easy enough to believe that complexity is the price we have to pay for progress. But that's not always true. Sometimes progress is simplification. Sometimes progress is removing moving parts, shrinking the surface area of the system, yet still somehow expanding its functionality and power. So, my name is Steven. You might know me as Fractaled Mind on Twitter. And today, I want to show you my vision for how Rails 8 and SQLite together supercharge Rails as the one-person framework. I want to present the possibility of building applications that have all of this power, but are this lean and this simple. Because believe it or not, this is a viable application architecture today, and one that can serve tens of thousands of users. You see, to extend the metaphor, like liquid methane and liquid oxygen in a rocket engine, SQLite and Rails, when mixed, form a potent combination. On the one hand, you have Rails, with its 2 decades of battle-tested solutions extracted from real production systems. And on the other hand, you have SQLite, with its 3 decades of refinement of this vision of having a operationally minimal embedded database with just a single file on disk and an executable that runs in your application process. And when you mix this conceptual compression with this operational compression, you get powerful and explosive results in what is a remarkably lean and simple application. So what I want to do today is show you how. And to start, I want to retread some of the ground that David went over yesterday to show you how Rails 8 specifically makes the Rails new command production ready. Rails has always been a full-featured framework that came with all of the components that you would need for a full-featured web application. And many of those components require some form of persistent data. We could call these the data-bound components of Rails. And a full-featured application is going to need a data store to back each of these. And of course, Rails is a modular framework, so each component has various adapters to work with different data stores. With version 7 of Rails, when you run Rails new, these are the production defaults that you would see. And there's nothing broken or wrong about these defaults, but these are not production-ready, plug-and-play solutions. The async adapter for jobs, right, is fast and simple locally, but if you run that in production, you are going to lose jobs on deploys or restarts. And the file system for caching works great if you have a persistent file system. If you're on Heroku, it's not so great when your entire cache is randomly wiped. Well, the Redis adapter for Action Cable, that's certainly production-grade software, but it isn't plug and play. You have to have a Redis instance configured and running and connected to your application in production. So, sure, production ready, but not plug and play. This is the major change with Rails 8. With Rails 8, you get an out-of-the-box experience that is both production ready and plug and play. With version 8, when you run Rails new, you're going to see these notably different defaults for the central data-bound components of Rails. This suite of solid gems provide production-ready, flexible, and scalable defaults for these components. And these database-backed, but database agnostic, of course, you can use them with Postgres, you can use them with MySQL. I hope by the end of this talk, you'll be interested to use them with SQLite. Offer a solid foundation for active job, active support cache, and action cable. And I hope that you were here in this room yesterday at this time to see and hear Rosa's talk where she detailed what makes SolidQ truly production-grade software. And last year at Rails World, Donald introduced Solid Cache, detailing its thoughtful and, again, production-oriented design. And unfortunately, Nick isn't able to be here today, but the work he has done on Solid Cable allows you, again, to have simple, scalable, agnostic, default experiences for your Rails applications. But Rails 8 being production ready isn't simply about these new defaults for Rails components, because Rails 8 also comes with an improved out-of-the-box solution for production deployments with Kamal. Right? Kamal offers everything you need to deploy and manage your web application in production with Docker. And yesterday, Donald introduced the new version of Kamal, Kamal 2.0, and Kevin introduced the new Kamal proxy. So I hope you were here to see what the future of deploying and running Rails applications looks like. But if you weren't, you can catch it on YouTube. All in all, Rails 8 provides the tools that you need to go from Hello World to Hello Web, just with Rails new. And these are the features and details that make Rails the one-person framework. As David outlined in his keynote last year, and reiterated with his haiku this year, Rails aims to be a bridge over complexity that allows the smallest possible team, right, you and your laptop, to build full, rich, valuable web applications. And SQLite aligns perfectly with that vision. I like to say that SQLite supercharges Rails, because SQLite is what enables you to go from the moderate complexity of a minimally distributed system to the radical simplicity of an application and all of its operational dependencies living on a single machine. And this is possible because of SQLite's unique architecture. Most client-server databases run in a separate process, often on a separate machine. But SQLite runs embedded within your Ruby process and the thread that spawns it. So it's not a database in the way that you might be used to, right? It's just a file on disk and an executable that runs within your application process. Nonetheless, it is a full-featured SQL engine with CTEs, window functions, aggregations, and anything else from the SQL standard and many things that aren't in the SQL standard. And this is stable software. SQLite's current major version, version 3, was released 2 decades ago in 2004. And today, there are an estimated 1 trillion SQLite databases in active use around the globe, making SQLite the single most used database in the world. And I would forgive you if you presume that an embedded database could only possibly manage a small fraction of the data that a proper client-server database can handle. But, of course, you would be wrong. SQLite can handle databases up to 280 terabytes. Or, to put it otherwise, you won't hit its computational limits, right? I promise. And when you pair the power and simplicity of SQLite with modern hardware, hopefully you're starting to get a sense of how SQLite enhances the vision of Rails as the one-person framework, enabling us to radically simplify our application's operational needs. But as I say this, I know that we have had years and years of people consistently saying that SQLite simply doesn't work for web applications. Indeed, for the last few years, if you ran SQLite in production, Rails would tell you it doesn't work. Go elsewhere. And the last time you read the Rails guides, it explicitly warned you against using SQLite in production. But this is an outdated point of view. And the reality is that today, this sentiment is a myth. And more people are starting to realize it. The fact of the matter is that this myth, though, persists for a reason. It does have foundations, because SQLite, in the context of web applications, is easily misunderstood and misused. You see, unlike much of modern software, SQLite cares more about backwards compatibility than it does about enabling newer and more powerful features by default. The maintainers care deeply that a SQLite database created 2 decades ago will be able to be opened by SQLite 2 decades from now. And that is one of the key reasons why SQLite is the archival format for digital data by the US Library of Congress. But this means that, for all intents and purposes, if you run SQLite out of the box today, it's as if you're running SQLite as it was created 20 years ago. And it's true, 20 years ago, SQLite was not well suited for web applications. So SQLite needs fine-tuning. And luckily, over the last 2 decades, there have been many features added to SQLite that do make it suitable for web applications. All that is needed is to fine-tune its configuration and its usage. And that is precisely what myself and the Rails core team and the rest of the Rails community have been doing for the last 1.5 years. And that work is finally culminating in Rails 8. Many of these pull requests have been released in various previous versions of Rails, but there are 2 in particular coming out with Rails 8 that warrant special consideration. Because these changes make Rails 8 the first version of Rails, and as far as I know, the first version of any web application framework that provides a fully production-ready SQLite experience out of the box. So the two issues that hindered the default experience of SQLite on Rails up till now were, firstly, that as your application was put under more and more concurrent load, a growing percentage of your requests would simply error out. You can see here that even at just 4 concurrent requests, nearly half of the responses are errors. And of course, this is utterly unacceptable for production. The second problem related to your application's tail latency under, again, increasing concurrent load. You would see your P99 or even eventually your P95 latency skyrocket. And when some requests are taking 5+ seconds to respond, it's fair to say this is not production-ready software. Both issues arise from the nuances of using an embedded database in a multi-threaded web application. Since Rails spins up multiple threads to process incoming requests, and each thread has its own embedded connection to the SQLite database, in fact, its own connection pool, Rails must ensure, firstly, that those connections don't conflict, but also that they don't block. And to ensure that these embedded connections don't conflict with each other, we had to make changes to the ways in which Rails manages transactions for SQLite databases. And to ensure that these connections don't block each other and create these latency problems, we actually had to work on a pair of pull requests, one in the lower level SQLite gem, which is the engine that drives SQLite through Ruby, and then the other in Rails to make use of this feature. Now, unfortunately, I don't have the time today to dig into the technical details, but if you are interested in learning more, I have an in-depth post on my blog that walks through every detail of these changes, the nature of the problems, the reasoning behind the solutions, and the details of the implementation. But details aside, the results speak for themselves. Not only do we no longer see errored responses, but our P99 latency is literally improved 1,000 times under heavier concurrent load. And in fact, we can see that these improvements hold steady even for the very slowest requests in our benchmark. These configuration and usage changes require nothing of you in your application code. And they unlock the full power and speed of SQLite, which now makes SQLite a viable production option. You can now back 4 out of the 5 data-bound components of Rails with SQLite without compromise. And this is precisely what unlocks this architecture as a viable option. A full-featured Rails application with no compromises on features or performance, all running on a single machine. Now, again, I recognize that this is a somewhat radical suggestion. And I expect that many of you are thinking right now that this architecture couldn't possibly serve production-level workloads. So let's quickly investigate. And I want to start with using the Campfire app released earlier this year by 37 Signals, both because it's a full production-grade, full-featured application, but also because the team at 37 Signals that built it provided a load testing tool in the source code itself. Now, Campfire does not go all in on SQLite. It was built before all of these solutions were in the framework, but Rails is a modular framework, so I just swapped the adapters out. And as a side note, this took me literally 45 minutes. And once I had the solid gems in place, Rails 8 as the version of Rails, I ran their load tests. And again, the results speak for themselves. Whether you're looking at the number of connections spawned or the number of messages received, the Campfire on SQLite fork performs just as well as the standard Campfire build. And the team at 37 Signals ran load tests on big, beefy servers, and they were able to handle 50,000 concurrent users, no problems. But we don't have to only look at this speculative load test. There are applications today that are running on this architecture. This is the Ruby video app built by my friend Adrian Pauly. It runs on a single $4 a month Hetzner box with SQLite backing all of its I/O needs, and it has served millions of requests with an average response time of less than 100 milliseconds, and it has 4 nines of uptime. I have also been running applications in production with SQLite. Unfortunately, they're all proprietary and associated with NDAs with big corporations, but I can tell you that these applications have been running smoothly for 3 years. They have driven millions of dollars in revenue, and they have never had a complaint from customers or from the business. Of course, recently Tech Twitter has been chatting incessantly, it seems, about Peter Levels' setup, where he runs multiple successful applications, all backed by SQLite, on a single beefy VPS. And as a reminder, single server deployments have been serving Rails applications quite well since day one. So yes, it really is possible to run a full-featured Rails application in production with no compromises on a single machine. So I hope that you trust me, or you're at least beginning to trust me when I say that this idea is a myth. And next year, I'm hoping to hear stories from some of you about applications that you have created and are now running for months successfully, so we can add even more evidence to show that this is simply no longer the case. But I don't want to stand here and make it seem like this is some sort of silver bullet, because it isn't. There are use cases where this architecture shines and those where it doesn't. And there are areas where you do need to be considerate. Firstly, when running SQLite in production, you need to have a solid backup mechanism set up. And I know this because I have deleted my production database, and it was not a fun weekend. I think that the best tool for the job is Lightstream. This is a utility that streams each change to your database to some S3-compatible bucket storage system that you have configured. You could even stream it to an FTS server that you've set up if that's your cup of tea. So you get point-in-time backups with incredibly cheap storage costs. And since it's only a single Go executable, I've wrapped it up in a precompiled binary gem, so installation is a breeze. And the gem provides a Puma plugin, so you could manage the replication process with a simple single line in your config. So it truly is a plug-and-play solution. And it even ships with a verification job that you can schedule to run continuously every day at midnight if you want, to verify that your backup system is working. Aside from data resilience, probably the most common worry I hear centers on the fact that SQLite only currently supports linear writes. And the worry is that only having one operation at a time will prevent your application from scaling, whatever that might mean. But this worry is overblown. Firstly, most applications are read-heavy, not write-heavy, so likely only around 20% of your traffic is writes. Plus, we easily forget what a difference it makes when you're using an embedded database. Even if you are running Postgres on the same machine as your application, the simple inter-process communication overhead means that you could execute 10 SQLite queries linearly in the same amount of time that it takes to run one Postgres queries. And as applications are generally moving away from self-hosting and managing their own database server, and cloud databases are more popular than ever, when using a cloud database, even if it is in a neighboring region, you could run 600 SQLite queries in the time it takes you to execute that one Postgres query. So when you go from a client-server database architecture with network latency to an embedded database, your queries go from being measured in milliseconds to microseconds. And that mostly erases the problems that you might think come from only allowing linear writes. But if you are ingesting lots of data, and by a lot I mean something on the order of magnitude of like 50,000 writes per second,
Probably SQLite won't work for you. Use Postgres, use MySQL. That's fine. Use the tool that's best for your problem. But if you're not at that level, SQLite is going to work fine and have no meaningful impact on your application performance. But linear writes do mean that you have to be thoughtful about migrations. If you have a long-running and write-intensive migration, like adding a new index to a table with 1 million or 10 million rows, that migration will impact your application's performance. And there are currently no popular or battle-tested solutions to get around this limitation, so be aware that such migrations are going to be handled much more simply with just scheduled downtime. In general, getting familiar and comfortable with scheduled downtime is going to be useful if you want to embrace SQLite, because SQLite works best on a single machine. And this means that as you need to scale, you should simply expand the size of that machine over time. Now, there's a fair chance that many of you imagine that the size of machine that you can rent is relatively limited. But you can rent a really big box, like a really, really big box. Any person who signs up on Hetzner can get a 48-core, 192 gig of RAM, 1 terabyte of NVMe SSD space for $350 a month. That thing is a beast, and it's available to all of us. So don't put an artificial ceiling on how far vertical scaling can take an application. And I know that we've all been told for the last decade that the only correct way to build web apps is with redundancy and high availability and automatic failovers and 0 to infinity auto scaling and everything else. But the fact is that these are solutions to problems that a minority of web applications do have or will ever have. And they come with real trade-offs around operational complexity. We need to remember that the larger the surface area of our systems, the more opportunities for failures. So ask yourself, do you truly need all of that? Especially on day one. Or should you start with a stack that is simple enough to keep in your head, yet powerful enough to serve all of your customers' needs? So like any tool, SQLite comes with trade-offs. And you need to learn that tool, its quirks and idiosyncrasies, if you want to make maximal use of it. But when you choose high leverage tools, tools that are well built and well known, tools that might be considered boring, you unlock the power of simplicity. And you truly can build an application that has the power to take your next idea to IPO. But you don't need to be a rocket scientist to run it. Rails 8 and SQLite strip away all of the incidental complexity, leaving you with the leanest, simplest, but most powerful application stack that I could imagine. And few things are as powerful as the tools that have earned their simplicity through years of evolution and consideration. These are the kinds of engines that empower individuals to build production-grade, full-featured, valuable applications faster, simpler, and cheaper than ever before. And I really, truly believe that we are on the cusp of a new wave of opportunity for Rails developers to make their stand in the greater marketplace of the internet and pursue their dream of building something that can sustain their livelihoods while pursuing their interests. SQLite and Rails are a unique pair, a powerful pair. And I hope that after this exploration, you better understand and appreciate how well SQLite pairs with Rails as an engine for creativity and building. And I hope you feel confident that you could, or even that you might want to, build and run your next Rails application going all in on SQLite. So, thank you.